Hello everyone, welcome to this particular video. My name is Bapi Ahmed, and in this particular video we'll be discussing about another amazing concept inside Python called list. List is nothing but it's a data type and data structure inside Python. As of now, we have discussed different data types inside Python like integer, float, boolean, strings, and so on, right? And that time I told you there are some more data types are available inside Python like list, tuple, dictionary, and sets. So we'll be discussing these are the data type one by one. So in this particular video, I'll discuss this particular list actually data type inside Python. So we also call this particular list as a data structure inside Python. Okay, because the way actually it stores the data. Okay, this is a completely different from your integer, string, and float, right? So if you complete this particular video, each and everything would be clear about the list. There won't be any kinds of doubt. I'll make sure. The way actually I'm going to show you this particular list concept inside Python, everything would be clear in your mind. So make sure you watch this particular video till the end. And after completing this particular video, if you have any kinds of doubts, so feel free to comment in the comment section. Definitely your doubt would be resolved. So first of all, let's try to see what are the things we're going to cover in this particular list concept. So guys, here you can see, so these are the topic actually we're going to cover inside this particular list. So definitely, first of all, we'll be discussing about like what is list. So here I'll try to give you the detailed introduction of this particular list. Then we'll see like what is the difference between list and array. See, in other programming language, we call this particular list as arrays. Like C, C++, Java, in this particular programming, we call this particular concept as arrays. If you are already from like other programming background, I think you already know like what is arrays, right? But in Python, we call this particular concept as list. Okay, not arrays. I'll show you some difference between list and arrays. Then this particular concept will be more clear. Like what is the functionality inside list and what are the functionality inside arrays and how they stores the data inside a memory. Okay, I'll discuss each and everything. Then we'll discuss the characteristics of a list. Then we'll see like how we can create a list. Then we'll see like how we can access any kinds of item from a list with the help of index. Then we'll see like how we can edit items in a list. Then we'll see like how we can delete any kinds of item from a list. Then we'll be learning different operation on top of this particular list. Then we'll be discussing about like list method, like list inbuilt functions and method. Then we'll be also learning about list comprehension. Okay, so these are the topic actually we'll be covering one by one in detail. And after completing these are the topic, definitely there won't be any kinds of doubt inside this particular list concept. And going forward, whenever you will be using this particular list in your programming, definitely you can use this particular concept very easily. So first of all, let's discuss what is list exactly. So you can see list is nothing but list is a data type where you can store multiple items under one name. More technically, list act like a dynamic arrays, which means you can add more items on the fly. Okay, now here you can see I have given one example. So L is a list, and inside this particular L I have stored you can say multiple items. Okay, you can see inside L I have stored multiple items. So as of now, we saw in a variable we can only store one value. Okay, I think you saw integer, float, then string. We only can store one value. But here list is a different kinds of actually data type. What you can do inside a variable, that means inside a name, you can store multiple items. You can store multiple items, and this particular item can be any kinds of data type. Okay, you can see the first item, it's an integer. Second item, it's a string. Third item, it's a float. And the last item you can see, it's a list. That means list itself you can also store inside a list. That is also possible here. It's like very powerful data structure, very powerful data type. Okay, inside Python. And whenever you define any kinds of list and you store items inside a list, automatically again it will create an index. The things we have learned in our string, I think remember, whenever you define any kinds of string, by default Python will create an index, okay, of each and every character. So similar wise in list also it will create an index. You will see that this particular 20 is present at the index 0, then 1, then 2, then 3. Okay, because in programming from 0 your count has started, right? That's how actually it will also assign the index from 0 to so on. Like how many items you will be present in that particular list, so that many of index number would be present there. Okay, this is the idea. Let's see if I want to access this particular 20. So how I can access? I'll just write L this particular let's say square bracket, and inside that I need to pass the index number of that particular item. Okay, now you can see index number is 0, and if you give it 20 will come from this particular list. Okay, this is the idea. Just give me some time, I'll show you how we can access the item from a list. Okay, so first of all, I will discuss why this particular list are required inside programming and why it is so important. So let's say you are working with Zomato company. I think you know Zomato is a food delivery company. Okay, Zomato company. and your task is to collect all the ratings, okay, all the ratings provided by the, let's say, user, okay, for some specific food. So your manager told you to collect all the ratings and store these particular ratings in a variable. Now just try to think how you are going to store let's say those ratings. Let's say in Zomato there are 100, let's say there are 100 actually users, okay, there are 100 users. So you have to collect all the 100 ratings and you have to store in a variable. Okay, so I think you are thinking I can store like that. Let's say user 1, okay, user 1 equal to, let's say, rating, this particular user has given, let's say, 7.5. okay, then I'll create another variable user 2. Let's say he or she has given 8.5, or let's say user 3, let's say they have given, let's say, 9.5, and so on, okay, till 100. Okay, user 100, you will create this particular variable, okay, and you will store the rating. Let's say he or she has given, let's say, 10 rating. Okay, so that's how you are thinking to create 100 variable. But do you really think it's an efficient way? It's an efficient way to store all the ratings here? Definitely not, because you have to create 100 variable here. Now just try to consider in Zomato, let's say 1000 user has increased. Okay, 1000 user have increased. Now what you will do? Okay, you have to create 1000th variable that time. So it's not an efficient way to store this particular ratings here. So what I can do, I can simply use this particular list type data structure. So here what I can do, I can simply create a list. Let's say list name is user is equal to, and if you want to define a list, you have to use this particular square bracket. Okay, I think I showed you that particular example, this particular square bracket, and inside that you will store all the ratings. Let's say 7.5, then let's say 8.5, let's say 9.5, and so on. Okay, let's say till 100. Okay, till 100 you have stored all the value. Okay, now you can see inside only one variable, I'm able to store 100 ratings. I'm able to store 100 ratings instead of creating 100 separate variable. Okay, see, this is the efficient way to store this particular ratings. So whenever you will be creating this kinds of real-time application, well, whenever you will be creating this kinds of real-time product, so definitely you have to know how to store the data efficiently. Okay, and this is called data structure. Okay, this is called data structure inside Python also. Okay, structure. This is the way actually it is stored the data efficiently. Okay, so that means this particular list also can be called data type. Okay, also can be called data structure. Okay, data structure. Okay, both it can be called. Okay, I hope this part is clear now. So that's why this particular list data structure is very important inside Python, because it helps you to store the data in an efficient way. And trust me guys, whenever you will be creating different application, this particular list data structure you'll be using a lot. Okay, this particular list data structure you will be using a lot. So make sure you are learning this particular concept in detail. Okay, and I'll make sure the way actually I'm going to teach you this particular list, there won't be any kinds of doubt. Okay, so now we'll just try to discuss the difference between array and list. Okay, see, in other programming language, I already told you, in C, C++, Java, we call this particular data structure as array, but in Python we call this as list. Okay, but there's some difference between this particular array and list. First of all, let me show you. See, whenever I'm talking about array, okay, it is having fixed size. Okay, fixed size. That means whenever you are defining any kinds of array, let's say, I think you remember in C how we used to define an array. Let's say, first of all, I'll define the type of the array. Okay, like what kinds of data, like what types of data it can store in that particular array. Let's say I want to store integer type data, and here I have to mention the array name. Let's say array name is equal to A. Now I have to define the size of that particular array. Let's say if I give 10, so it can only store 10 actually items inside this particular array. Now inside this particular curly bracket, I can store all the value. Let's say 1, 2, 3, ... 10. Okay, I can store this particular value. So that is how actually we usually define any kinds of array in other programming language. Okay, and it's a fixed size. Whenever you are creating this particular array, you have to define this particular size. Okay, it's a fixed size. Now let's say Now let's say you want to add another number in this particular array. So here it's not possible because you have already defined the size of that particular array and all the 10 number you have stored. So it won't be allowing you to store that particular additional number here. Okay, that is the problem with this particular array. Now the second things you will see inside array, it's a homogeneous. Okay, homogeneous. Homogeneous means you can only store one type data. That means if you have created integer type array, you can only store integer type data. So here you can't store any kinds of string type data. You can store any kinds of boolean type data. You can't store any kinds of float type data. It's not possible here because you have defined this particular array would be integer type. Okay, this is called homogeneous. You can only store one type data. Okay, one type data, which can be, let's say, integer, which can be, let's say, boolean, which can be float. Let's say I want to store boolean type data. So what I have to do? I have to create another array. So the array type should be boolean. And here you can give any kinds of name, let's say B, and you have to define the size of this particular array. Let's say size is 5. Okay, now inside that you can store the value. Okay, so it can only store boolean type data. It can't store integer type data in this particular array. So this is called actually homogeneous. Okay, homogeneous. Speed of execution, it's fast. Okay, inside array it's fast and it takes less memory. Okay, less memory. So these are some actually characteristic of an array. Now let's try to discuss about list. So let me just write down list. So list is a dynamic, okay, dynamic size. It's not a fixed size, it's a dynamic size. Dynamic size means you can store as much as value you can. Let's say here I have defined a list. Let's say I'll define a list. Let's say L is equal to, this is going to be my list. So here you don't need to pass any kinds of size. You don't need to assign any kinds of size of this particular list. You can directly just write L is equal to, and you can define the list. Let's say 1, 2, 3, 4, okay, 5, and so on. Okay, let's say this is my list. Now let's say in future I want to add some more number. Let's say I want to add 6 and 7. What I will do, I'll just extend this particular list. Okay, it can easily store this at the number as well. Let's say 6 and 7. Okay, 6 and 7. That means there is no fixed size. Okay, there is no fixed size. You can store as much as value you can. And how it is storing this particular value in the memory, I'll tell you. Okay, in detail I'll tell you how array is storing the value in the memory and how lists are storing data in the memory. I'll tell you each and everything. I'll tell you. So this is what actually dynamic. Now I think you got it. What is the difference between array and list? Array is a fixed size and list is a dynamic size. That means whenever you are initializing this particular array, you have to define the size of that particular array, and here you don't need to pass that particular size. It can store as much as value it can. Now there is another characteristic inside list. It's a heterogeneous. What is heterogeneous? It can store multiple data types. A list can store multiple data types. I think I showed you one example. So here I think you remembered. I can store integer type data, I can store string type data, I can store float type data, even I can also store a list type data itself. So any kinds of data I can store inside a list. Okay, there is no restriction. That's why it is called heterogeneous. Okay, this is called heterogeneous, but which is not possible inside array. Inside array you can only store one type data. Let's say you are storing integer type data, you can only store integer type data. You can't store any kinds of float type data there. Okay, so this is called homogeneous and this is called heterogeneous. And inside list, this speed of execution is a little bit slow. Okay, slower than array. I'll tell you why it is slower than array. And it takes more memory. Okay, more memory to store the value. Again, I'll tell you why it takes more memory, okay, than your array. So these are some difference between our array and list. I hope this part is clear right now. And now I think this particular definition is clear. List is a data type where you can store multiple items under one names. Okay, that means this is one variable. Inside that I can store multiple items. And more technically, list act like a dynamic array. Dynamic means you can store as many as value you can here. There is no fixed size. You can add more items on the fly. That means I already told you, you don't need to give any fixed size. Let's say you want to add more items. Immediately you can add that particular item inside a list. Okay, there is no restriction. So guys, now I'm going to show you how this particular array and list like store the value in the memory. Okay, what is the memory representation of this particular list and array? Okay, I think then this part would be more clear. Then this part would be clear why arrays execution is usually fast and why it takes less memory, and why list execution a little bit slow and why it takes more memory. Okay, so first of all, let me show you about the array, like how array stores in a memory. So let's say you are having one array, let's say int a. The size of the array is, let's say 4, and this is the array, let's say 1, 2, 3 and 4. Fine. Now whenever you define this particular code snippet in the memory, what will happen? It will create a memory block, okay, with size of 4. That means size of 4. You can see 1, 2, 3, 4. Then this particular value will be stored. So let's say 1, 2, 3, 4. This particular value will be stored. But see, this particular raw value won't be stored. Instead of that, it stores always the binary representation. Okay, binary representation of 1, 2, 3 and 4. So here I can write binary. Okay, binary number. And this particular memory block will have some of the address. Let's say the address is, let's say 1001, 100, let's say 4, 1006, 1008. It can be any kinds of number. It can be any kinds of random number. Fine. So this is the representation. Okay, this is the representation of an array in the memory. Okay, that's how one array can be stored in the memory. So here you can see, whenever I'm defining this particular array, it will create this particular memory block in a continuous manner. Okay, continuous manner. That means one after another. Okay, that means it follows the continuous order. Now let's try to see how list stores the data inside a memory block. So let's say here you are having one list. Let's say AL is equal to let's say 1, 2 and 3. So at the very first, what will happen? These are the value would be stored in a memory block, in an empty memory block. Let's say empty memory block means, let's say this is my memory, and there are so many blocks in the memory. I'm giving you a high level overview how things are working. It's not the actual drawing I'm doing. Just try to consider. See, memory can't be always empty, because in your system there would be so many software running. So definitely some memory block would be blocked already. Okay, with some other application, with some other data. Let's say this memory is blocked. This block is blocked. Okay, then this space is blocked. Then this space is also blocked. That's how some of the space would be blocked. Now, whenever I'm talking about empty block, let's say whenever you define this particular list 1, 2, 3. So what will happen? It will come here and it will look for. So where this particular let's say block is empty. So this particular block is empty. So it will come here and store 1 here. Okay. Then it will look for this particular block is empty. Again, it will come here and store 2 here. Then this particular block is empty. It will come here and store 3 here. Okay, that's how it will store this. These are the item. So let me just draw it one by one. Let's say the address of this particular block is 500. Fine. And inside that it has stored 1. Fine. Now the next block. Let's say the address of this particular block is, let's say 700. And inside that it is having, let's say 2. Now we can see 3 would be stored in another block. So let's say the address of this particular block is 800. And inside that I'm having 3. Fine. So that's how initially your value would be stored in the memory block. Now what will happen? You can see the size of this particular list is 3. So it will create 3 blocks. It will create 3 blocks. Fine. And inside this particular three block, it will store the address of the item. So that means the first address you can see, it's 500. Second item address is 700. And the third item address is 800. And this block will have also some address. Let's say the address is 1001, 1002 and 1003. That means what is happening? Instead of directly storing these are the item, it is storing the address of that particular item. That means you can see this particular block is pointing to this particular block. This particular block is pointing to this particular block, and this particular block is pointing to this particular block. That means we call this particular array as a reference array. Okay, reference array, because it is storing the reference value. Okay, it is storing the reference value. Value means the address of the item. Okay, the address of the item. That means it is storing the reference value, or you can also call it as pointer. Pointer. This particular concept maybe you have learned in your C++ programming. What is pointer? Okay, so this is called actually pointer. It is pointing to this particular block. That is the idea. Now whenever I want to let's say access any kinds of value in this particular list, first of all I will go to this particular block, and this particular block will give me the address of this particular item. So it will go here, this is the address, and this particular value would be returned. Okay, this particular value would be returned. Okay, this is the idea. Now I hope you got it. What is the difference between this particular array representation and list representation? So array can be stored directly in the actually memory blocks. Okay, and it will create a continuous actually block. Inside that you can store the value, but inside list, instead of creating the direct value block, we just create a reference block. Okay, we can create a reference block, and we just try to map. Okay, we just try to map with the actually value block. You can see this is a value block, and it is pointing to this particular block. Now from this particular example, I think you are automatically getting why it is taking more memory. This particular list is taking more memory than your array. You can see it is creating two different blocks. That's why it's taking more memory. All right, it's taking two memory. It is storing value as well as the reference address of that particular value. And why this particular array is speed is a little bit fast, because you can see you can directly access this particular value. You don't need to go to any reference actually address. That's why it's a little bit fast. But here if you see, if I want to get this particular value, first of all I need to go to this particular address, then again it will look for that particular address. That means the reference address of this particular value. That's why it's a little bit slower than your array. Now let me show you one amazing practical demo of this particular representation. I think then this particular concept will be more clear. So I'll go to my code editor, and here I'm going to just define a list. Let's say L is a list, and inside that I'm storing some value. Let's say 1, 2, 3. Now if you want to see the memory address of this particular L, that means this particular list. So what you can do, you can use this particular ID function. Okay, ID function. Inside that you can pass this particular object, this particular list object. Now if I execute, it will show you the memory address of this particular list. So in this particular memory address, this particular list is stored. Now if you want to see where this particular one is stored, okay, in which address this particular one is stored, for this what you can do, I think I can use this print function. Inside that I can write now I want to see this particular one. So for this I'll just write L index 0. If I give L index 0, that means it's 1, right? Then if I want to see the 2, it would be 1. And if I want to see the 3, it would be 2. So with the help of index, actually I'm accessing these are the value one by one. Now if I see, if I execute this particular program, see this is my entire L memory address. That means the list memory address. And this is the address of the 1. This is the address of the 2. Okay, and this is the address of the 3. Now see what I will do, I'll just write ID of 1. I want to see in which address this particular 1 is stored. I also want to see the 2. I also want to see the 3. So instead of printing it, I can copy this particular code and I will execute at the second cell. Now you can see this particular number and this particular number is same. This particular number and this particular number is same, and this particular number and this particular number is same. That means what is happening whenever you define this particular list. So what will happen inside a memory block, it will first of all create some of the block and it will store the value. Let's say 1. Then it will store, let's say 2, and it will store 3, and it will have some address, right? So let me take a new color. Now you can see this is the address number, the one address number. Okay, one address number is that. So I'll take the only last 3 numbers. So let's say 4, 3, 2. Then 2 address number is 4, 6, 4, and 3 address number is 4, 9, 6. Fine. Then what will happen? It will create a memory block. The size of your array, you can see it's 3. So 1, 2, and 3. And inside this particular block, it will store these are the address. That means 4, 32, 464 and 496. Fine. And this is my entire array. Okay, this is the entire array, and the address of this particular entire array is this number actually, 104. Fine. So whenever you are calling L0, that means you want to access the first item in that particular list. So what will happen? It will redirect here. Okay, it will redirect here in this particular location and it will return you 1. And whenever you are calling this particular one and you want to see like why this particular one is present, you can see it is giving you this particular address. It is giving you this particular address here, this particular address. Okay, so that's how actually this thing is working. I hope this particular practical is clear, how it is storing that particular value in the memory. Okay, the things I have showed you as a theoretical in my board. Now I think I also proven with the help of practical representation as well. Okay, so similar wise, whenever you are checking the 2 address, you can see it is printing 464, and whenever you are checking 3 address, it's printing 496. Okay, that's how it is storing the value inside memory. And how it is replacing that particular homogeneous, that means you can also store multiple data types here, because you can see, let's say you want to add any other type data, let's say you want to add A here. So what will happen? It will create another block, and inside that it will store A. Okay, and this will have some address. Let's say address is, let's say 900. Fine. And here one block would be created. And inside that it will store the address of that particular A. Okay, and it will point here. That means here you are not directly storing this particular item. Instead of that, you are storing this particular pointer, this reference value. Okay, that's how actually you can replace this particular homogeneous concept. You can store any kinds of data. And which is not possible inside array. Because array, you can see it will directly store this at the value. So here I can't create another block, and you can't actually store A here. It's not possible because you have mentioned it's an integer. Okay, you have mentioned it's an integer. I hope this part is clear now, right? Now the next thing we'll be discussing about why it is dynamic and how this particular dynamic works. Dynamic means you can add as much as value you can. And now I will show you how it will store these are the value. Let's say initially my array size is, so here I can write. So let's say L is an array, and here I'm having, let's say 1, 2, and 3. So what will happen in the memory block? It will create 3 block, and it will store 1, 2, and 3. Fine. Now let's say I want to add 4 and 5 in this particular array. So what will happen? I can easily add 4 and 5. Now in the memory, what will happen? So it won't be replacing in this particular block. Let's say this is my block A. So it will create a copy of this particular block. That means the double size. That means let's say this is a 3 block. It will create another block which is size, the size would be 6. Double number block it will create. Let's say 1, 2, 3, 4, 5, 6. So what it will do? It will copy all the number one by one. 1, 2, 3, and it will store 2 number. The new number you have given, let's say 4 and 5. That's how it will do the copy operation. Okay, it will do the copy operation. It will create a copy with a double block size, right? Now let's say you want to add some more number. Let's say you want to add 6 and 7. Again, what will happen? It will create another copy. Let's say the block would be C. It will create another copy with that double size. It will copy all the number 1, 2, 3, 4, 5. Then it will store 6 and 7. This 6 and 7. And so on. So in future, if you want to add some more value, again it will create a copy of this particular block with a double size, and it will store that particular value. Okay, so sometimes what happens, let's say you create a double block, but you don't use that particular block. Let's say this particular block is empty. So you are unnecessarily taking this space. Okay, unnecessarily taking the memory. So that's why list always takes more memory. Here I told you. And why speed is slow? Because of this particular operation. It will create a copy every time. Okay, it will create a copy different time, and it will copy all the value. Okay, in the new actually block. That's why this particular execution is a little bit slow than your array. I hope this part is clear right now. What is this particular dynamic and how this particular dynamic works? And I have proven all this particular statement one by one. Now let's try to see some characteristic of a list. Now you can see the first characteristic. It's a ordered collection. So let me show you why it is an ordered collection. Let's say L is a list, and here I'm storing some value. Let's say 1, 2, 3. Okay, let's say this 3 value I'm having inside a list. So I can name it as L1, and I will take another list. Let's say L2. L2 is another list, and it is also having the same number. But what I can do, I can just change this particular number. Let's say 2 will come at the first, then let's say 3, then 1. Now if I just write L1, okay, L1 equal L2. Now just pause this particular video and tell me the output. What will be the output? It will be true or false. See, if I execute, it would be false. Why it is false? Because you can see it's not ordered. It's not an ordered collection. All the value are same inside this particular let's say list. Items are same, 1, 2, 3 only. But this is not in the same order. You can see first of all 2 is coming, then 3, then 1. So that's why ordered is mattered. Okay, in the list. Then it's a changeable and mutable. So you can change any kinds of value inside this particular list. I'll tell you whenever I'll do the let's say edit operation. I'll tell you how we can change any kinds of value inside a list, how we can delete any kinds of value inside a list. Okay, I'll tell you each and everything. So it's a mutable, but in string we have learned string was immutable. We can't change anything inside a string, but in list actually you can change anything. That's why it's mutable. It's changeable. It's heterogeneous because you can store multiple type data, float, string, character, anything you can store here. Okay, that's why it's heterogeneous. It can have duplicates. Duplicates means, let's say you can also store duplicates value. Let's say you can also give 1, still it will work. Okay, now these are dynamic. Dynamic means you can add as much as value you can. I already proven, okay, in my board, I think, remember. Can be nested. Nested means you can also store list inside a list. This is called nested. And items can be accessed. I told you item can be, let's say I want to access this particular 1. Okay, 1. So if I want to access this particular 1, I need to give the index of the 1, let's say 0. Now I can access this particular 1. That's why item can be accessed. Can contains any kinds of objects in Python. Okay, so whatever objects having inside Python, it can store any kinds of objects. Okay, inside a list. I'll tell you this particular part at the last of this particular discussion. So I hope guys this particular list introduction is clear. I have given the detailed introduction of this particular list. Even I showed you lots of things inside this particular list. And I think so far I have recorded a long video on this particular list. Okay, in this particular playlist. Now we'll see that how we can create a list, how we can access this particular list, how we can edit it, how we can delete it. Okay, and operation will be learning each and everything. So guys, now let's try to see how we can create a list. So here you can see I have mentioned different list. Like these are the way actually we can follow to create a list. So the first approach you can see, we can create an empty list with the help of this particular square bracket. Let me show you. So let's say if I take a new cell and if I just write, let's say L is equal to this particular empty bracket. Now if I execute this particular program, see it's a empty list. So if I show you the type of L, it's a empty list. Okay, so if you want to create an empty list, that time you can use this particular square bracket. Okay, only empty square bracket, no need to give anything inside that. Now if you want to create a one-dimensional list, I think you know, like one-dimensional array, two-dimensional array, right? So in a list also we can create a one-dimensional list, two-dimensional list, and three-dimensional list, and so on. But we usually try to use till 3 to 4 dimensional, because as you go ahead it would be more complex. We don't use it. I have seen like people are using 3 to 4 dimensional list only. Okay, not like beyond that. You can see if I want to create a one-dimensional list, I can create like that. So I can copy this particular list, and here I can mention, see, this is my one-dimensional list. Okay, this is my one-dimensional list. Now you can see inside this particular list we are having only integer type data. Now you just pause the video and tell me it's a heterogeneous or homogeneous. Yes, I think you are correct. It's a homogeneous because we are only storing one type data here. Okay, yes. Now if you want to mention two-dimensional list, you can mention like that. So inside the list actually you can take another list. This is called two-dimensional. Okay, two-dimensional. And now you can pause the video and let me know whether it's a heterogeneous or homogeneous. Yeah, it's a heterogeneous because you can see this is actually integer and this is actually list. Okay, this is integer, this is actually list. That means multiple data type you are storing, it's a heterogeneous. Now you can also create a three-dimensional list like that. And how you will identify whether it's a three-dimensional or not, you can see the first 3 bracket and the last 3 bracket. Okay, so how many bracket is coming at the first and last, we can consider like that. Let's say if it is coming 4, that means a 4-dimensional. Okay, and if it is coming 5, it's a 5-dimensional. Okay, that's how. So it's a 3-dimensional actually list. Now one heterogeneous example I will show you. See, this is one heterogeneous example. You can see in this particular list I'm storing integer, boolean, float, then a complex and string. Okay, all kinds of data actually I'm storing. It's a heterogeneous list. Now you can also do the type conversion to create a list actually. So there is a list function is there. Inside that, if you give anything, it will convert that particular data to the list. Now let me execute this particular program. Let me show you all the output. You can see this is my empty list. This one my one-dimensional list. This is my two-dimensional list. This is my three-dimensional list. This is the heterogeneous, and this is the type conversion. Okay, you can see hello I have given, it's a string type, and whenever I convert it to list, you can see all the individual character would be present as an item, okay, in this particular list. So these are the way actually we can follow to create a list. Okay, I hope this part is clear. So guys, the next topic we'll be learning how we can access any item from a list. For this actually I'm going to use this particular list. So here we'll be learning two things. Let me just mark down it. We'll be learning like how you can perform indexing. Okay, indexing, and we'll be performing the slicing. The same thing we have learned in our string. Okay, string also I think you remember. In string also we have learned this particular indexing and slicing. See why I prefer this particular Python, because see in Python all the syntax are same. Okay, all the let's say working mechanism are same. The things you have learned inside string, the same thing can be also applied in the list also. The same thing can be also applied in the tuple also. Okay, same thing can be also applied in the let's say sets also. So everywhere you can perform this particular accessing operation. So here no need to teach anything new. The same thing we have used in our string, like slicing, then string indexing, that means the string manipulation, whatever we have learned, everything can be performed inside this particular list also. So let me show you one example. Let's say this is my list. Now let's say I want to access this particular 1. So if I want to access, what I have to do, I have to give the index of the 1. So I'll give inside this particular square bracket, index is 0. Now see, it will give me 1. Now let's say I want to access this particular 5. So what I will do, 0, 1, 2, 3, 4. So index number is 4. It will give me 5. So this is called actually positive indexing. Why positive? Because you are giving positive number. You are going left to right, left to right. Okay, whenever you are going left to right, it is called positive indexing. You can also perform negative indexing. Let's say I want to access this particular 5 with the help of negative indexing. What I will do, I'll give -1 that time. It will give me 5. If I want to, let's say, extract this particular 4, I'll give -2. It will give me 4. The same thing we have learned in your string. The same thing can be applied here also. So I'm not going to teach you this particular part, guys, in detail, because I already discussed this particular things in detail inside my string class. So whenever I was discussing about this particular string, okay, string, I think you remember this particular notebook. So string in Python. So here I have already discussed this part. Let me show you. Here I have already taught you this particular concept, like how we can perform the indexing operation, the negative indexing, positive indexing, slicing, everything I taught you here. The same thing you can apply inside the list also. Nothing new. Got it? So this was my one-dimensional list. Now I will show you some of the example on top of this particular two-dimensional list. Okay, I will copy this particular two-dimensional list. I want to show you how we can access the two-dimensional list. Let's say this is my L2. This is my two-dimensional list. Fine. Now let's say here I want to access this particular 5. So how I can access this particular 5? So for this, first of all, what I have to do, I'll just call this particular L2. See, first of all, if you want to access this particular 5, first of all, you have to access this particular list. And what is the list position? You can see 0, 1, 2, 3. So at the 3 position, this list is present. Now if I just give 3, see, this particular list will come. This particular list will come. Okay. Now I want to extract this particular 5. I want to access this particular 5. And what is the index of this particular 5? You can see 0, 1. Now here I have to give another square bracket, and here I have to mention the index number. Now see, it will give me the 5. Okay. That's how we can access any kinds of two-dimensional list. Now let's say I want to extract this particular 4. What I'll give? I'll give 0 here. It will give me that particular 4. So first of all, you have to access this particular list. Then inside this particular list, whatever value you are having, you have to give this particular index. So this is for the first list. This is for the first list. This is for the second list. Okay, that's why it's called two-dimensional. Okay, two-dimensional list. I hope this part is clear. Now let me show you the 3D as well. So I'll copy this particular 3D. So you can also do the same thing with the help of negative indexing. For this, what you can do, L2. Let's say I want to take this particular list. So this is at the last position. I'll give -1. It will give me that particular list. Now I'll access this particular 5. Okay, so here I'll give it is present at the last. I'll give -1 again. Okay, it will give me this particular 5. With the help of negative indexing, you can also do the same thing. Now let me show you the 3-dimensional one. So this is my 3-dimensional array. Now let's say I want to access this particular 4. So first of all, what I have to do, first of all, I will check how many lists are present in this particular list. So I'll give length, and inside this particular length function, I'll give this particular list, and see, it is giving me 2. That means 2 lists are present. So you can see this is one list, this is another list. Okay, now first of all I will extract the first list. I will access the first list. So to access the first list, I'll just write L3. I'll give 0 here. If I give 0 here, see, it will give me the first list, this particular list. This particular list it has given. Now see, again, if you check this particular type, in this particular list, we are having two lists. If I show you the length, if I show you the length of this particular list, you will see inside that we are having two items, which is also a list. Now I want to extract this particular 4. 4 is present in the second list. That means if you count the index, it is 1. That means if you count the index, it's 0 and it's 1. So what I will do, I'll first of all access this particular list. So for this, I'll give this particular index 1. Okay, so it will give me that particular list. You can see 3 and 4. Now I want to access this particular 4. Now what is the index of the 4? It's 0, 1. Okay, again I have to give 1. In another square bracket, I have to give 1. Now see, 4 I'm able to access. Now you can see 3 square bracket I'm using. So it's called 3-dimensional list accessing. Got it? I hope this part is clear. Now I'll give you one question. Let's say I want to access this particular 5. Just comment out that particular code, what you will be writing here if you want to access this particular 5. So let me show you. Let's say if I want to access this particular 5. So first of all, I have to check the length. You can see length is 2. That means two lists are there. First of all, I will take this particular list out. So for this, I'm going to use this particular index 1. Now it will give me this particular list. Now I want to enter in this particular list. So what I will do, I'll go to the first one. Now I want to extract this particular value. I'll give 0. Okay, now see, 5 is printing. That's how actually we can also access 3-dimensional list. It's very easy. It's very easy, guys. If you just do it by yourself, it would be more clear. Now with the help of negative indexing also, you can perform the same thing. Now we'll be seeing the slicing operation on top of the list. Again, it's the same thing only. Whatever things you have learned in your string. Let's say I will copy this particular list and I want to perform slicing on top of it. So let's say I want to slice, I want to take access this particular 1 and 2. So what I will do, I'll give L, this square bracket. I will start from 0 and I'll see like what is the index of 2, 0, 1. It's 1, but I have to give 2 here because last number would be excluded. Now if I give 2, now see, 1 and 2 would be printed. And again, the output I'm getting, it's a list only. Fine. Now let's say you want to access till, let's say you want to access 3, 4 and 5. So how to do it? So simply just count the index 0, 1, 2. So from 2, I will go till last. Okay. So if you go till last, you can give empty. Now if I execute this particular program, you'll see that 3, 4 and 5. Now if I give like that, let's say L. So what with the output, it will give me the entire list because here I haven't given any kinds of minimum range and maximum range. Okay. It will give me the entire value. Now if I give like that, let's say so here I will give, let's say, so here I will give, let's say 2. So what will happen, it will jump. Okay, it will jump one actually item. You can see it's a jump parameter. If I print this particular array, so first of all 1 will be printed, then 3, then 5. That means it is jumping one item. If you give 3 here, it will jump 2 item. This is a jump parameter. That means whatever things you have learned in this particular string in Python, the same slicing, okay, you can apply here. So I'm not going to discuss this particular part because I already discussed it here. So if you haven't watched that particular video, just try to check this particular video. This thing would be more clear. Because see, at the end, everything is same only. Okay, I don't need to repeat anything. So this is what actually we can perform slicing operation inside a list. So guys, this is all about from this particular video. In the next video, we'll try to see like how we can delete, how we can edit, how we can perform operations. We'll be also learning the list inbuilt method and function. Okay, so these are the topic we'll be discussing one by one. So with that guys, thank you so much guys for watching this particular video and I will see you next time.